Hello, welcome, and thank you very much for your interest today in this lecture. As already said in the introduction, this is my first time here in India, so I feel very honored and very thankful to be invited here from our partners Unicorn Dental to having me here today. Unfortunately, my Hindi is not very good, so I can only say Namaste and Bahut Bahut Dhanyavad for your interest, and thank you, and for the rest I will continue in English. So, just a short introduction of myself. Okay, so my name is Julian. I worked in the southern part of Germany several years as a dental technician in different laboratories, and have now the lucky position to be a technical sales consultant for the VHF Confecture to support this company with the knowledge that I gained in the last years being a dental technician. So, here you will also find my contact information. If you have any ongoing questions, feel free to contact me. Also, I'll be standing there at booth A1 with Unicorn. So if you have any ongoing questions later, then please feel free to come up and let's have a conversation. So what is the program for today? So we're speaking about titanium milling. And as you can also already see, we started the milling process. We have inserted our blank and we start milling in titanium. So while the machine is running, I would like to introduce the VHF, our milestones, so you know where we're coming from, what is our passion, and why we will provide you with the perfect solution for milling implant prosthetics. Then we will speak about the problems with titanium milling and why we can solve these problems. And then I will also give you some practical tips for your personal workflow that you can implement in your personal workflow to have the best practice when it comes to titanium milling. Then I would like to introduce the hybrid milling, and if this is all maybe a little bit too technical for you, then just stay with me, because later on we will also have a look at some clinical cases to rise up your interest for this topic. So what is the VHF Confecture again? We're a company located in the south of Germany, and right now we're employing around 350 people, and we have one passion, and our passion is to build milling and grinding machines. We have one factory, this is also located in Germany, our headquarters. Here are all machines produced, tested, and then shipped in the whole world. So every machine you will find on any place on this world is coming from this one facility that is located in Germany. We're actually split up into three groups, because we not only provide you with milling machines, we have also the VHF tool company that is providing us with all the milling tools for the machines, and the VHF electronics company that is making all the software and the control boards for us. So you get the complete CAM solution out of one hand, and with this we're right now the only manufacturer on the market that can provide you with the complete CAM solution from the software to the tools to the machine. We are an open system. So we are making the machines, but we have a lot of partners when it comes to design softwares. We're working with several design softwares together, and also with a lot of different material distributors. So we have a big library for prefabs and all kinds of materials. And located in our headquarters, we have over 50 specialists that are providing you with service. So this is not only me, we have our support team, we have a repair team, we have a technical team, and a lot of sales consultants that are always there for you, answering your questions. And so these are our key facts. We have been founded in 1988, so more than 30 years ago, by three people. This is also where the name is coming from. We started here in the southern part of Germany, so near Stuttgart. And right now we also have office in the United States, and we opened an office in Shanghai to also provide you with support and a hotline in all different kind of time zones. We're producing industrial machines, dental machines, and also the tools, as well as the software and the electronics. And this is how we started. So in 1988 we were founded by these three people, and they came up with a design software. So it was only a design software for these control boards. And then a few years later they enhanced this software to be capable of calculating a milling path, and then also of controlling a milling machine. And this is when we came up with the first software that is able of designing, calculating and controlling and then we started producing our own CAM systems. They were all individually manufactured and were running for several years, and then about 10 years later we started to introduce our first lines, and they are still on the market since more than 20 years now. And we can, especially here in this active line, we can provide you with machines up to 8 meters length, all custom built. So this is where our expertise in milling coming from. Then in 2007, the dental market, some companies stepped up to us and asked us, can you build a dental milling machine for us? And so this is when we produced our first desktop machine, so not 8 meters big, but capable of putting on the table. And that was the part when we entered the dental and the jewelry business. And then in 2011, we came up with the K4. That was our best-selling machine, which was hitting the market really good. And yeah, that was the point where we started rising on the dental market. 2 years later, we introduced our first 5X milling machines, and also, this is very interesting because already in 2013, we were able to transfer this 5X machine into a dry milling machine. This is also interesting when it comes to milled titanium, because you need a wet option. And also the first machine with a blank changer, so for continuous working. Then after this, we split up our portfolio into our specialists, like the N4 for the wet grinding, the K5, another 5X dry milling machine, and we also remade the K4 because it was still performing so good on the market. And the K4 was actually on the market till last year, so in more than 10 years we have been producing this machine, and this shows that the interest was very big and the performance was very high. After that, we completed our portfolio also with newly designed machines, and there we added to start smart features. We added smart features in the machines. So for example, here the first machine that we had for the dental office, with an integrated computer, with an integrated compressor, touchscreen control to make everything most comfortable for the dentist. And then also mostly for the lab, we introduced our flagship machine that is still our biggest and best running machine on the market. So we have a compact desktop milling machine, but is capable of fully automatically switching between wet and dry milling. It has a 10-disc changer, so you can put all the materials in the machine, design, and then let the machine run overnight. After the portfolio was completed, we started to update the existing specialists, like the K5 Plus, also the N4, the S series. So then our portfolio was updated and completed, and since this year we're happy to introduce a completely new generation of milling machines that is now added to our portfolio, and this is the so-called East class. So we have now 3 machines, completely new system. They're super lightweight, they're easy to use, so you just set them up, you plug them in your computer, and you start milling. And because, especially here, our E5, this is the 5X dry milling machine, all the machines are completely free of compressed air. So we're making them more independent. So this machine is not only for the dental lab, you can make it flexible in the dental lab, in the office, because you can set it up everywhere and then just start milling, because we have here our air tool. This is a turbine that will provide you with an airflow, so we don't need any kind of compressor anymore. The same is here with the E4. This is also a super lightweight machine, less than 30 kilos, so you can just take it by yourself, put it on the table. You can use it in the dry and in the wet mode, capable of milling our complete portfolio of blocks. You're open, so you can choose whatever kind of material you want and start working. And since this year also we have the E3, and this is not a milling, not a grinding machine, this is a trimming machine, completely new on the market, for trimming out aligners in under 1 minute. It comes with our own software, so you can process aligners also in your office with the E3. So this is our new East class since this year. But we were speaking about now the titanium milling and the implant prosthetics. So what kind of machine is interesting when it comes to processing implant restorations? So first, we can speak about titanium abutments. So this is when we have our N4 Plus, because this is not only capable of milling grinding blocks, but you can also insert an abutment holder, and with the abutment holder you're able to manufacture different types of prefabricated abutments. We have a really big library, so more than 200,000 different prefabs from all kind of different manufacturers that you can manufacture with this machine. Then when you not only want to make the abutments but also the restoration, we have here our S5. This is one of our best performing machines because it has also here a blank changer on the side, so you can make your abutments and you can make the structure over the abutments. And with the optional wet grinding module, you can also make this machine capable of milling titanium. And of course, here again our R5 machine. This is the best machine when you're speaking about big restorations, because you can make any material, any indication. You can insert blanks up to 40 millimeter height, so you're not limited to any kind of material. You can make the abutments, you design it, and then you go home, and the machine will mill the abutments for you. It will mill the implant bar for you, and also whatever kind of overstructure you want to design in any kind of material. Is it zirconia, composite, lithium disilicate, whatever you want to use, this machine is doing it while you're at home. So these are the machines that we can provide you with when you're working on implant milling. And now it comes to the main topic, the metal and titanium milling, and why we can do this. So again, I want to point out, I want to step back here to our history. So the biggest question, or the most asked question when I go to an expo, is always, what kind of spindle power does this machine have? And then I say, okay, here for example our R5 machine, it has a spindle power of 800 watt. This is our most powerful spindle. And then the people ask me like, 800 watts is your most powerful spindle, but there are other manufacturers that are using like 3 or 4 times the power. How can you can't mill metal with this? And for me this is kind of funny, because when I think back that in 2011, when we had the K4 Plus, the K4, not even the K4 edition, we had a 240 watt spindle. And we started making metal on this machine already in 2011. So it can't be only the spindle power, because we just did it. And why can we do this? Because we have our tools, we have our software, and we're having the experience coming from the industrial branch that is giving us the possibility to make metal already since more than 10 years. So this is the parts that we can provide you with. Thank you. I have also here some water bottles and some blanks that I, especially the one you saw in the video at the beginning. This one I brought to here, so you can have a look at it later. If you want, just come over and have a direct look at it. So we are providing you with a machine part. This is what we can offer you. We can offer you the machine, the software, and the tools. And now, when it comes to milling implant prosthetics, this is also the complete workflow, but this is in your hands. So we're an open system. We cannot tell you what kind of material you use. It's your choice. We cannot look at the design you make. It's your choice. And of course, we don't know what kind of scanning device you use, because this is also your choice. And when you have a small offset already at the beginning, and then you transfer this offset to the design, and then you use some kind of material with its own characteristics, then you will create an error that is growing from each step, and then you will end up with a offset, an individual offset to the machine. And this is why I say the errors can accumulate, and you cannot compensate this error just by throwing more spindle power into the machine. You have to know your workflow, and then you have to see what kind of offset you have in each step, and then how to compensate this. And this is why I said let's make sure that these errors don't happen, and have a look at the best practice. So the first thing that is very important is when it comes to designing, because as you saw in the picture, the design step is very at the beginning. So here you define already your parameters for later. And we will also have a look at how to find your individual parameters for your individual workflow. This is just also a basic example that it's also important to have a milling-friendly design. Because here, this is no implant bridge, for example, but it's a good example because you can see what is a non-milling friendly design. And I mean, it's also not necessary because you have like this, it maybe looks nice, but you have this tiny gap in here where all the food will get stuck and it's difficult to clean for the patient, so why do you want this? And with just a simple smoothing, you can open up this gap, and so it's easier for the patient to clean. But also, as you can see here, the machine, either you have the problem that the machine will tell you, okay, I can't go inside here, and then you will have rest material that you have to take out by hand, or even worse, the machine is going inside the gap here, and then the tool will just stuck. And then it will break, or you will damage your material, and then you have to start all out from the beginning again, and this is not useful. And so you can compensate this error with just a little bit of, when you keep in mind how big is my tool diameter. Do I have drill compensation in my CAD software that is already looking at the diameter of the tool for me? Use these tools to make a milling-friendly design, also without 90-degree angles, and then you have already like 90% of the errors compensated. The same goes also when it comes to the nesting. This is also a little bit technical, so we will step through this faster. Take a look at your screws, that you set them equally. You don't have to be afraid to set a lot of screws, because our software is also capable of cutting the screws away after the milling. So you don't add work for you, you just add more screws for security, put them equal, and then you tell the software, okay, when you're finished, then put away this, and this, and so the object is at the end holded by the last two screws, and you can take out the object by hand with less work. Then of course here, this is the same like in the design step. This is not bringing any effort to the stability, it's just making it difficult for the machine to mill and has the risk that the tool gets stuck. Also a point that is important when it comes to metal milling or hard materials, this is not for zirconia or PMMA, but very crucial and a small tip when it comes to metal milling, look that your workspaces are not overlapping. And why? For zirconia, this is working super fine, you can save space, but not for hard materials. But when this object is gone, there's air. And so every time the tool will go around the second object, it will go from the material into the air, and then back into the material, and then in the air again. And every time it goes back into the material, you get a little punch on the drill. And this will slowly lead to structural errors in the tool or in the collet chuck. And just facing the risk of a tool break or that you have to replace the collet chuck. And so for zirconia you can do this, or for soft materials, without any issues, but when you're making metals or titanium, then just make sure that each object has its own workspace, because at the end you're saving more money without risking tool breakage than you're saving material. So when we're speaking about the tools, this is also an interesting topic. So I want to shortly introduce these tools to you, that you understand what kind of shape is doing what. So as I said, we have the machines, then we had our own strategies, and then we were thinking about, okay, we need a tool for the beginning to take away a lot of material without losing its lifetime. This is when we come up here with the big one in the middle. This is our R4 tool, because we added 4 cutting edges. And so we have 4 cutting edges that are going through the material, taking away a lot of material without risking to reduce the lifetime of the tool. Then when we come to implant bars, for example, we have, or occlusal surfaces, we of course need also a small tool. This is here our M60 tool, so 0.6 millimeter diameter, that is capable of making the rotational protection of your implant construction, for example. So this tool is very useful when it comes to small areas. And maybe the most important tool when it comes to titanium milling is this one here, because as you can see here on the T, it is not shaped round, it has a flat top. It has round edges, so the edges are round, so you can enhance the lifetime of the tool, but top of the tool is flat, and we can use this to flatten out the surfaces, and these are very important later for the connection of the implants. So this is very important to get this tool if you're making implant connections. So of course we have our original tools. We have also a tech liquid that you can add when you mill titanium, and to enhance the lifetime of the tool additionally. And also, if you want the best result, then you may have to get optional tools, but it's worth it because there you can enhance the quality a lot. Well, then the material. We don't have any material, and so we are open, it's your choice. And we had a problem with CAD/CAM optimized materials. So there was some customers stepping up to us and saying, hey, we're using this kind of material, it says CAD/CAM optimized, but we are having fitting errors, we're having tool breakage, what is happening? And so first we were a little bit clueless, and then we looked at the technical sheet, and then we saw that this CAD/CAM optimized materials were harder than, had a Vickers hardness of more than 800 to 900. And okay, you can use this, but this is way too much. This is really hard, and it's not necessary because we're making our tests with materials of around Vickers hardness of 300, and there you get the best results. So not all CAD/CAM optimized materials are really good. When it comes to titanium, this is also an interesting fact because there's a little bit opposite. You have in titanium different grades. You have grade 2, you have grade 4, and you have grade 5, and the hardness is raising. And with our new dental cam, we have strategies also for the lower grades, but there we had to reduce the speed because the material is so soft. And so if you're going with titanium milling, then I can only recommend to use very hard titanium grade 5 because this is much easier for the tools to be cutted. So also for the people that are maybe using already our CAM software, as I already said, take a look here. You can activate optional tools. You have the button for the implant geometry, and there you can activate optional tools to later process the implant connection. And now, this is the last slide from the technical part, but this is maybe the most important, because now we will see how you can find the individual parameters for your workflow. And this is super easy because you have these two sliders here. And with these sliders, you will find your individual parameters. So when, in my old laboratory, when we got our first R5 machine, we started with a test. We made a test object, and we looked how it was fitting. And in the moment it was a little bit too tight, we just added a little bit here on the slider. And with this slider, you can make your object wider or narrow. And then we did this a few times, like 2 or 3 times, a little bit too wide, then we closed it a little bit, until we had our perfect fitting. And then when you see here, you see a number, and this, if you remember the picture from the beginning with the offset from the design, from the scanning, from the material, because the number at the end, this is your personal offset for your workflow. And then you can take this number and either add it in your CAD software already in the design at the beginning, or you leave it here. This is up to you. But this is the best way because you have all your errors accumulated, and at the end you check what is your complete offset that is coming at the end to the machine, and there you can compensate it. So to summarize this, for the best accuracy you need, of course, quality tools. Look for a hard grade 5 titanium, check your individual parameters, and make a milling friendly design. Also use the DentalCam 8 strategies. So this was the technical part. And now for anyone who's new to titanium milling, I would also like to introduce our new possibility of hybrid milling. Because since a few weeks we have the possibility to combine the advantage of laser sintering with the advantage of milling machines. And how does this work for our machines? You get your objects out of your laser sintering device. And then it looks like this. We're completely open again to any kind of laser sintering device, so you can use whatever you like. you just need the special kind of CAM software that is called Make and Mill. And then you can either use the K5 Plus for cobalt chrome or our S5 for titanium. And what you do then is you define in your software, you can define already, okay, I have my object here, and this occlusal surface I want to have polished later by the machine, or as you can maybe see here at the bottom of the abutment, you can see the lower side is marked, so I want to have the bottom of the abutment polished later by the machine. And this you send to your laser sintering device, you print out your object, and then you put it back into the machine. We have a special holder here for our VHF machine. This is a so-called spider holder, and this is the final result at the end. So every surface that you mark will then be processed by the machine, and we can also make this a little bit bigger. I tried to make the photos with our photographer. Here are some dusts left because the surface was so flat and so smooth that you can even see the last parts of dust. But you have here a perfect surface, you have here a telescopic crown, and also the complete implant connection is completely milled by the machine. But this is all very nice. I mean, I can tell you now, we can do this, we can do this, we can do this, but we also need proof. We also need to know that this is working, what I'm saying. And so we try to come up with a scientific solution to prove the fitting of our objects. Because I mean, you can mill it out, you can give it to someone on a model and say, it's not shaking, so it's fitting. But we want to have like a really accurate proof of the accuracy. And so what we did is we take an implant bar and we put it in our R5 machine. With the Dental Chem 8, we have the indication implant bar and we have the quality setting put on optimal. This is the titanium that we have been using, also with all the 4 tools that we provide for metal milling. And then we used this device. This is standing in our quality department, and this is a high quality 3D scanner. It's super slow, but it's super accurate, so you use it in the medical industry or in aerospace engineering. And it's really slow when it comes to scanning, but it has an accuracy that can scan below the range of microns. And this scanned result we put into a so-called GOM Inspect software. This is also a quality measurement software that comes from the industry. And this is how it looked at the end. So we just scanned the parts that are important for the implant bar, so only the connections. And here you see the screenshot a little bit bigger. And now we took this data from the scanner and layered it over with the original STL. And now you can also see why it's so important to look at the design. Because here, I don't know if it's good to see, but we have here, for example, 90-degree angles. And if you put these 2 STLs together, you get some really interesting results. Because you see, here, these areas are red. But this is okay. This is completely logical because we don't have 90-degree tools. And so what the software is doing, it's flatten out the surface. And this is why it's so important to have milling-friendly design, because this 90-degree angles here can't be processed by the machine. But the important part is, here, all the flat surfaces, here the big ones that are made by the bigger tools, and especially here, the circles around that are connected later with the implant, you can see no deviation at all. And so this was for us a very interesting proof of this concept that is important to look at the design, because all other surfaces can be milled perfectly, especially around the implant connections. But the best proof of concept is always the practical. So we have also some clinical cases that we did. We have been working together with a doctor, he's living also in the southern part of Germany. And what we did is we made some upper and lower restorations with a milled implant bar and then a bridge later on it that I just want to introduce you. So this was the initial setup. So we had here 4 implants in the lower jaw, This is how it looked after setting the implants. And then we milled the implant bar, but this time out of PEEK. And why out of PEEK? Because, well, I was speaking now a lot about titanium milling and the technical facts, but for those people who also want to get introduced to implant milling, this can be very interesting, because we have here our PEEK bar, we have our sintered zirconia bridge. This is the result at the end. We also made a try-in, so this is the result with the try-in. And here at the end, you see the finalized result in zirconia. Unfortunately, because this case is really new, right now we're working on the upper jaw, so I cannot provide you with any final pictures of the upper restoration as well. But I've also here this case from the upper jaw, so we had also some kind of restorations in the lower one, and a little bit of rest tooth in the upper. They have all been extracted, and the implants have been set. And here again we have the restoration. So again we have the zirconia bridge with a PEEK implant bar. And here this is the result at the end. Luckily the lip line was really good to hide the threshold between the restoration and the gingiva. And then we could provide the patient with a new smile. So why these cases with PEEK and zirconia? Because we have big machines. We have the R5 machine, we have the S5 machine that is capable of making heavy titanium restorations. You saw we have the proof, the scientific proof that we have the fitting of the cases. And for those who are new into implant restoration, we have the E-series. And with the E-series, especially with the E5, you get a small and lightweight machine that is easy to handle, easy to service, completely user-friendly, and free of compressed air with a working angle of 35 degrees, so you have the complete freedom of design. And for a very reasonable price, you get a machine that is also making this kind of restoration. So this is a complete ease restoration, because again we started with PEEK, we have a VAX trial, so all materials that are capable for the ease class. We have the zirconia bridge. We have the two objects set together. We had also some kind of rest tooth here in the back. This is the combined result. And this was the finished restoration, completely made on the ease class for our patient. So you're super independent and mobile with the highest quality restoration in soft materials, because you're capable of making all these kinds of indication here on this small and lightweight machine. For the heavy materials, we have again the S5, the K5 Plus, and the R5. And there you see the final result, and with some pictures and impressions of how the process is working, I will end this for you. So here you see again the torical tool is going into the material. Now you see the processing from the other side. We have the 5-axis, so we have also the capability of making angulated screw channels in all kinds of materials. And with this, I wish you happy milling. Here you see the result. This is actually the photo taken from this blank, so you can look at it later. And yeah, thank you very much for your attention.